Hello, welcome back to Tutor Think. In this video, we are taking the Laplace transform of f of t equal to e to the power negative 2t. This video is an example to the previous video, Laplace transform of f of t equal to minus at. So I told you in that video that we are using a to represent a scalar, and this is an example. So locate that video finding the Laplace transform of f of t equal to e to the power negative at. You see the concept, that is what we are applying here. So this is a short one. Kindly subscribe to this work. I'll not be really explaining these formulas because I've done these explanations in my previous videos in this same playlist. So please locate these videos, the introduction to Laplace transforms. Watch them accordingly. All right. So the Laplace transform of a function f of t is given by L of f of t equal to the integral from 0 to infinity f of t e minus st times dt. Okay, we know f of t to be this one, so we can put it there into this formula. So this is giving us Laplace transform of e minus 2t, giving us 0 to infinity e minus 2t times e minus st dt. Okay, so I just substituted this one there. Now the next step is to work on this one using indices. Usually I interchange the position of this and this is multiplication is commutative to help those of us that are very weak understanding these things. I know, so please pardon me. Let me do that for the sake of those who find it difficult to understand these things. I need to break the equation down for them. All right, so this here is the same as 0 to infinity e to the power negative st times, because I want to factorize my t out and start with s. Okay, so e to the power negative 2t dt. There's no need for you can jump this step. Okay, now when we get here, we will just pick one of the base, integral of 0 to infinity e here. Then because I have t, I'll factorize it out. I have negative, I'll take one out. So this is negative into s plus 2, close the bracket, t. Okay, now this time this will give you negative s times this t will give you negative st. This time this will give you minus 2 times the t. You have this result. Okay, then you can split it. All right, so we have dt. Now in the next step, we will just integrate this function and we are off to go. Now for exponential function, if this is your first time, if we have e to the power, let's say 2t, then the integral of this is gonna give you 1 over 2 e to the power 2t. Okay, or you can also have e to the power 2t all over 2. Remember that this is over 1, this time this is this time that is that. So we are having a fraction. Okay, I just factorize 1 over 2 out, the same result. So if I have minus s plus 2 here, it is also serving as the coefficients of t. Okay, so 1 over that result you raise to the same exponent. Very simple. So from here, if I want to integrate this, because I want to substitute in the limit 0 to infinity, let me start from here. So we have 1 over negative s plus 2. I'm not adding t because this side is the coefficients of the variable t, raised to the same power negative s plus 2t. Okay, now integration has already taken place. This is out. Introduce your upper and lower limit. So put this in brackets. This is 0, this is infinity. Remember, I do not want to take limit here. I am jumping so many steps. This is very simple because there's no need for me to take it. So if I want to take limits, I need to substitute this with, let's say, a, and then approach a to what? Infinity. So to make it very simple, substitute your upper limit and lower limit, and the result is upper limit minus what? Lower limit. For t, remember t is a real value for what? 0 and infinity. All right, so we have 1 over negative s plus 2. Then we introduce our upper limit for t. Then we have e negative s plus 2 into infinity, close this bracket, minus the same thing, negative s plus 2, there's a bracket here, 0, close this. Okay, so now this is upper limit minus lower limit. Remember that as t approaches infinity, the whole result here converges to 0, and this side is 1 because a variable to power 0 is 1. All right, so for instance, if I take the limit of e to the power, let's say negative t, then as t approaches infinity, this result is 0. Okay, so when you substitute a very large number here, this result will be 0. You can check this on your calculator. Punch this equation, pick a very large number to represent infinity, substitute it here, you will get a value that approaches 0. Okay, so now this side is 0, this side is 1. So we have 1 over minus s plus 2 times 0. The whole side here is 1, so we have minus 1. Don't forget there is a negative sign here. Don't ask me where did I get this negative. It is coming from here. Okay, so now the result is very simple. Use this to multiply this, use this to multiply that. This time this, we all know, is 0. Ignore it. This time this is what? A positive result. Negative, negative, you get a positive function. So this is giving us 1 over what? S plus 2. Very simple. So the Laplace transform of e to the power negative 2t is giving us 1 over s plus 2. Now this is it. You locate the video Laplace transform of e to the power negative at. That is an introduction to this one. Very simple. If you are asked somewhere to prove it, you should be able to do this. So thank you very much for joining me in this one. My name is Dan again, and I'll see you in the next one.